Find the missing term in the following table assuming that interval of difference in h equals 1. We are given the input values x equals 0, 1, 2, 3, 4 and f of x values are given as 1, 3, 9, blank, 81. We have to find out value of f of x corresponding to input x equals 3. Let us assume that f of 3 equals k. Since 4 values of f of x are given, we will assume that f of x is a polynomial of degree 3. Since we have the result, whenever f of x is a polynomial of degree n, delta raised to n plus 1 applied on f of x equals 0. We have delta raised to 4 applied on polynomial of degree 3 equals 0, where delta is the forward difference operator. We have delta equals e minus 1, where e is the shift operator. Thus, we have e minus 1 the whole raised to 4 applied on f of x equals 0. We can expand e minus 1 the whole raised to 4 using binomial expansion. We have e minus 1 the whole raised to 4 equals summation r ranges from 0 to 4, 4cr e raised to 4 minus r into minus 1 the whole raised to r. Thus we have e minus 1 the whole raised to 4 becomes e raised to 4 plus 4c1 e raised to 3 into negative 1 the whole raised to 1 plus 4c2 e square into negative 1 the whole square plus 4c3 minus 1 whole cube into e raised to 1 plus 4c4 minus 1 the whole raised to 4 into e raised to 0. We have e raised to 0 equals 1. Thus we have e minus 1 the whole raised to 4 obtained as e raised to 4 minus 4 e cube plus 6 times e square minus 4e plus 1 applied on input f of x equated to 0. We have shift operator of order 4 e raised to 4 when applied on f of x, it will display the output f of x plus 4 because we have assumed h equals 1. When shift operator of order 3 acts on input f of x, the output displayed is f of x plus 3. E square acting on f of x will display the output as f of x plus 2. E acting on f of x will display the output as f of x plus 1. Thus we have the LHS obtained in this way. In this equation 1, we will give x equals 0 so that we can make use of the values f of 4, f of 3, f of 2, f of 1 and f of 0. We have been given the values f of 0, f of 1, f of 2, f of 4 and we have assumed f of 3 as k, and we will substitute all these values in equation 1 giving x equals 0 in equation 1. Now we obtain the equation f of 4 minus 4 times f of 3 plus 6 times f of 2 minus 4 f of 1 plus f of 0 equals 0. Giving the values, we get 81 minus 4k plus 54 minus 12 plus 1 equals 0. From where we have LHS obtained as 4k and RHS 124, taking all the constants without k to the RHS. Simplifying, we get k equals 31 and thus we have f of 3 equals 31.